Hello guys, welcome aboard Apex Math. My name is Bino. In this video, we go through question 4 from the N5 April 2025 question paper. Question 4.1.1, we integrate the following function and we have to use the use substitution method. And we have two options. Either we let u equal sin x or we let u equal 2 sin x minus 1. So let's let u equal 2 sin x minus 1, and the derivative of the u with respect to x will be equals to the 2 multiplied by the derivative of sin x, which is cos x, and the derivative of negative 1 is equals to 0. Moving on from here, we also have two options. Either we let the dx be the subject of the formula and we substitute it where there is that dx. So that dx, we make it the subject of the formula, or we make cos x dx the subject of the formula. So that cos and that dx, we make it the subject of the formula and substitute it into our integral. We start by removing that dx from the denominator. So we multiply both sides of the equation by the dx so that the dx can be cancelled, and our du will be equals to, so remember that that dx and that dx will cancel out, and du will be equals to 2 multiplied by cos x multiplied by dx. So we can make that dx the subject of the formula, but since we also on our integral we have cos x dx, we can make that cos x dx the subject of the formula and substitute it in our integral. So we divide both sides of the equation by 2, and du over 2 will be equals to cos x dx. So on our integral, in the place of cos x dx, we can substitute the du over 2. We can also write it as du multiplied by 1 over 2. So we have the integral of, so in the place of the cos x dx, we substitute du over 2 because it's equals to the cos x dx. So we have du multiplied by 1 over 2, and in the denominator we let u equal 2 sin x minus x. We can move that 1 over 2, since it's a constant, out of the integral. So we have 1 over 2 multiplied by the integral of 1 divided by u multiplied by du. And this will be equals to 1 over 2 multiplied by the integral of 1 over u, which is ln of u, plus our arbitrary constant c. And in the place of the u, let's substitute back the 2 sin x minus 1. So we have half multiplied by ln of 2 sin x minus 1 in the place of the u plus c. And this will be our integral for question 4.1.1. Question 4.1.2, we integrate the following function, and we are going to employ our formula sheet so that we can integrate, and we are going to use the identity which has 2 signs, since we also have 2 signs. We are going to use that trigonometric identity, and we are going to have the integral of a half multiplied by the cos of a. So the 7 over 3x will be our a, and the b will be the 1 over 4x. So we have the 7 divided by 3x minus the 1 over 4 multiplied by x. According to that formula sheet, we have minus the cos of 7 over 3x plus the 1 divided by 4x. We are integrating with respect to x. The 1 over 2 is a constant, so we can write it out of the integral. So we have half the integral of the cos of 7 over 3x minus 1 over 4x will be equals to 25 divided by 12 multiplied by x minus the cos of 7 over 3x plus 1 over 4x, which is equals to 31 divided by 12 x dx. And here, from here we can integrate, so we have the half multiplied by the integral of the cos of 25 over 12x, which will be the sine of the 25 divided by 12x. Remember that if we were differentiating, we were going to multiply by the derivative of the inner function, the 25 divided by 12. So now we are integrating. We are not going to multiply, we are going to divide. So we divide by the 25 divided by 12 minus the integral of the cos is sine of the inner function, the 31 divided by 12x. And if we were differentiating, we were going to multiply by the 31 divided by 12, but we are integrating, so we divide by the 31 divided by 12. We have our constant c. We have half multiplied by, so the 1 on our calculator, 1 divided by 25 divided by 12 will be equals to 12 divided by 25. So 1 divided by 25 over 12 will be 12 divided by 25. We multiply this by the sign. Also, I forgot the x, sorry about that. So we have our x, the 25 divided by 12x. So we have the sign of 25 divided by 12 multiplied by x minus, so again, 1 divided by 31 divided by 12 will be 12 divided by 31. We multiply this by the sign. The sign of 31 divided by 12 multiplied by x plus our constant c. So if you like, you can distribute that half inside the parentheses. I'm just going to leave my answer here. Question 4.1.3, we integrate the following function and we are going to use the u-sub method. But before that, let's write it as the integral of e to the power x divided by the square root. So we have the dx there, the square root of 3 minus, so the e is raised to the power 2x, so we can write e to the power 2x as e to the power x multiplied by e to the power x dx. We are going to let u equal e raised to the power x, and the derivative of the u with respect to x. The derivative of e to the power x is just e to the power x. We multiply both sides by dx, and that dx and that dx will cancel out, and du will be equals to e to the power x multiplied by dx. In the place of the e raised to the power x multiplied by dx, we substitute the du. So we have the integral of the du in the place of e to the power x dx, and we divided by the square root of 3 minus, in the place of the e to the power x, we substitute u. So we have u multiplied by u. Our integral will be 1 divided by the square root of 3 minus u squared. Du. To integrate, we can try to use the formula sheet, but the formula sheet doesn't have that 3. It has 1 in the place of the 3, so it's not going to give us the correct answer. I suggest you memorize the way that I'm going to do it. We were supposed to use the arc sign in a reverse, so we are supposed to reverse. So we have the integral of 1 divided, so memorize, we have 1 divided by the square root. The 3, we write it as the square root of 3, but we square it so that we don't change it, minus u squared du, and the integral will be equals to the arc sign u divided by the square root of 3 plus c. I think this formula is available on the N6 question paper, and this will be equals to, so in the place of the u we substitute back, so we have the arc sign of e raised to the power x in the place of the u, and this is divided by the square root of 3 plus the constant c. The full formula to determine this is only available in the N6 question paper, and that's the formula from the N6 question paper. Moving on to the next question. Question 4.1.4, we use long division method to evaluate the following integral, and the reason why we are using long division method is because the highest power is 3x to the power 3, and it's in the numerator, not the denominator. So we are going to use a long division method, and we are going to write the x minus 2 right here, and in here we are going to write the 2x cubed plus 8x squared minus 6x plus 10. And the first step is for us to, the 2x cubed, we divide it with the x, and 2x cubed divided by x is equals to 2x squared. And we take this 2x squared and we multiply it with the x minus 2. So 2x squared multiplied by x will be equals to 2x cubed, and 2x squared multiplied by negative 2 will be negative 4x squared. And we have to minus, so 2x cubed minus 2x cubed will be 0. 8x squared minus 4x squared will be positive 12x squared. And from here, we take down the negative 6x and we write it next to the 12x squared. And we take the 12x squared and we divide it with that x. 12x squared divided by x is equals to positive 12x. And the very same 12x, we multiplied with x minus 2. 12x multiplied by x is equals to 12x squared. 12x multiplied by negative 2 is equal to negative 24x. And we minus, so 12x squared minus 12x squared will be 0. Minus 6x minus 12x will be positive 18x. And from here we drop down the 10. We write it next to the positive 18x. Now the 18x divided by x will be equals to positive 18 and the very same 18 multiplied by x minus 2. 18 multiplied by x is equals to 18x. 18 multiplied by negative 2 will be equals to negative 36. And now we minus 18x minus 18x will be 0. 10 minus 36 will be equals to 46. So we have nothing to drop and we have the 46 as our remainder, which we have to divide with the x minus 2. And separately, we are going to have the 2x squared plus 12x plus 18. We are going to have the integral of the 2x squared plus 12x plus 18. So we have the integral of 2x squared plus 18x plus 12x, plus 12x plus 18. And we have our remainder, the 46, which we divide with the x minus 2. So that x minus 2. Now we are at liberty to integrate. It will be much easier to integrate this when it's simplified. So we have the integral of 2x squared, which will be equals to 2x raised to the power 2 plus 1 divided by the 2 plus 1. And the integral of the 12x will be 12x raised to the power 1 plus 1 divided by 1 plus 1 plus the integral of 18, which is 18x, plus the integral of 46 divided by x minus 2. So if we have this 46 divided by x minus 2, we can rewrite it as 46 multiplied by 1 divided by x minus 2. So we are going to have the 46, and the integral of 1 over x minus 2 will be the ln of x minus 2 plus our constant c. We simplify, and this will be equals to 2 divided by 2 plus 1. 2 plus 1 is equals to 3 in the denominator, multiplied by x raised to the power 2 plus 1, which is 3, plus 12 divided by the 1 plus 1. 1 plus 1 is equals to 2. So 12 divided by 2 is 6, multiplied by x to the power 2 plus 18x plus 46 multiplied by the ln of x minus 2 plus c, and this will be our answer. Question 4.1.5, we are going to integrate a log function, and to integrate a log function, we are going to use integration by parts, and the formula is the integral of f of x multiplied by g prime of x dx is equals to f of x multiplied by g of x minus the integral of g of x multiplied by f prime of x dx. When using integration by parts, we need two functions and we only have the log. So let's multiply the log by 1. So now we have two functions, the log and the 1. We have to decide which one will be the f of x, which one will be the g prime of x between the log and the 1. So we have to decide which one will be our f of x and which one will be our g prime of x between the log and 1. The f of x, we are going to differentiate the f of x so that we can get our f prime of x. The g prime of x, we are going to integrate it so that we can get g of x. So the function which will be easier to integrate between the log and the 1 is the 1. So it will be much easier to integrate the 1. So the 1 will be our g prime of x. Since the g prime of x is 1, the f of x will be the log. So f of x will be the log of base 2 of x. We are going to differentiate the log and integrate the 1. So the derivative of the log, let's look at our formula sheet, and we have that as the derivative of the log. So we are going to have 1 divided by x multiplied by the ln of the base. The base is 2, so we have ln 2. We integrate that 1. Its integral is x. Now we substitute into that formula. So the integral of the log of base 2 of x multiplied by 1 dx will be equals to the log base 2 of x multiplied by that x. So it will be the log of base 2 of x multiplied by x minus the integral of g of x multiplied by f prime of x. So our g of x is equals to x multiplied by the f prime of x, which is equals to 1 divided by x multiplied by the ln of 2 dx. The x and the x will cancel out. X divided by x is equals to 1. So this will be equals to x log base 2 of x minus, we take the 1 divided by ln 2 out of the integral since they are constants. So we have 1 divided by the ln 2 and we have the integral of 1 dx. And this equal x log base 2 of x minus 1 divided by ln 2 multiplied by the integral of 1. The integral of 1 is equals to x plus our constant c, and this will be our answer. Finally, for our last question, we determine the velocity of an object falling in air given by the following integral. So we integrate so that we can get the velocity, and we are going to integrate using partial fraction decomposition. Suppose that we have a squared minus b squared, a difference of two squares. This will be equals to a minus b multiplied by a plus b. We have 1 minus kv squared. The 1 can be squared, because 1 squared is equals to 1, and this will be equals to the integral of dv divided by 1 minus kv multiplied by 1 plus kv. Or we can remove that dv, so we can have 1 and place the dv there. In the denominator, we have 1 minus kv and 1 plus kv, so we have unique linear factors. We forget about the integral and the dv, so we have 1 divided by 1 minus kv multiplied by 1 plus kv. This will be equals to, because it's unique linear factors, we have a divided by 1 minus kv plus b divided by 1 plus kv. For now, we are going to multiply both sides of the equation by 1 minus kv multiplied by 1 plus kv. So we multiply by 1 minus kv. We also multiply by 1 plus kv. And what we do on the left, we do on the right. So even on the right, we are going to multiply by 1 minus kv multiplied by 1 plus kv. On the left hand side, the 1 minus kv will cancel out with that 1 minus kv in the denominator, and the 1 plus kv will also cancel out with that 1 plus kv. We'll be left with 1 is equals to, so let's distribute the 1 minus kv multiplied by the 1 plus kv. So we have a divided by 1 minus kv, which will be multiplied by 1 minus kv multiplied by 1 plus kv, plus b divided by 1 plus kv, and this whole will be multiplied by 1 minus kv multiplied by 1 plus kv. The 1 minus kv and that 1 minus kv will cancel out, and the 1 plus kv and that 1 plus kv will also cancel out, and 1 will be equals to a multiplied by 1 plus kv plus b multiplied by 1 minus kv. We have to determine the value of v, which will make the 1 plus kv equals 0, because 0 multiplied by a is 0, giving us an opportunity to determine the b. So for what values of v will 1 plus kv equal 0? So we solve for v, so kv will be equals to, we take the 1 to the right and we divide both sides by k, and v will be equals to negative 1 divided by k. We have 1 is equals to a multiplied by 1 plus kv. In the place of the v, we substitute negative 1 divided by k plus b multiplied by 1 minus k multiplied, in the place of the v, we have negative 1 divided by k, and the 1 will be equals to a into 1 plus, so that k and that k will cancel out and we'll have negative 1 here. So that negative 1 plus b multiplied by 1 minus, so the k and that k will cancel out. Negative multiplied by negative will be positive 1. So 1 minus 1 is equals to 0. So we have a multiplied by 0, but a multiplied by 0 is just 0, plus the b multiplied by 2. We divide both sides by 2 and the value of b will be equals to half. Now we got the b. To get the a, in order for us to get the a, we have to determine the values of v, which will make that 0. So 1 minus kv is equals to 0. Taking the kv to the right, 1 will be equals to positive kv. We divide both sides by k, and 1 divided by k will be equals to v. We substitute the v, so we have 1 is equals to a multiplied by 1 plus kv, but in the place of the v, we substitute 1 divided by k plus b multiplied by 1 minus kv. In the place of the v, we substitute the 1 divided by k. The k and the k will cancel out in both terms, and 1 will be equals to a into 1 plus 1 plus b into 1 minus 1. So the 1 minus 1 is equals to 0, and b multiplied by 0 is equals to 0. So we have 1 is equals to a into 1 plus 1. 1 plus 1 is equals to 2. Dividing both sides of the equation by 2, our a will be equals to half. So our b was equals to half, even our a is equals to half. Remember that we had to simplify our integral, so this is just the same as what we have. The right and the left are equal, so we can take the right because we know the values of a and b. In the place of the a, so this will be equals to, in the place of the a, we have half divided by 1 minus kv plus b, but in the place of the b was also equals to half, and we divide by the 1 plus kv, and we are integrating with respect to v, not x. So we have half multiplied by the integral of 1 divided by 1 minus kv, which is equals to the ln of 1 minus kv. If we were differentiating, we were going to multiply this by the derivative of the negative kv, which is equals to negative k, but we are integrating, so we'll divide by the negative k. So we divide by that negative k plus 1 over 2 multiplied by the integral of 1 divided by 1 plus kv, which is the ln of 1 plus kv. And if we were differentiating, we are going to multiply by the derivative of the kv, which is k, but we are integrating, so we are going to divide by that k. And this will be equals to, okay, so we forgot our constant c, so we have plus the constant c, and we are proving that velocity. So we are going to take the half as our common factor and also take 1 over k as our common factor. So we are going to have 1 divided by k, 1 divided by 2m, and multiplied by 1 divided by k into, let's write that positive ln first because of the logarithmic law that we are going to use, and then write the one which has that negative later on. So we are going to have the ln of 1 plus kv, and we have this one which is negative minus the ln of 1 minus kv. And the logarithmic law that we are going to use states that if we have the ln of a minus ln of b, this is equals to the ln of a divided by b. So we have that negative and we also have that negative there, so we can use this law. So this will be equals to 1 divided by 2k multiplied by the ln of 1 plus, so that a and that b divided, so that 1 plus kv will be our a, 1 minus kv will be our b. So we have the ln of 1 plus kv divided by 1 minus kv plus our constant c, and this will be our answer for this last question. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.